A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Think back to the last time you were using an LLM. Maybe you were asking about a specific library update or a breaking news event, and it looked you straight in the digital eye and lied. It gave you that classic, confident hallucination because its internal world ended 6 months or a year ago. We all thought search grounding was supposed to kill that problem for good by now.
It was the promised land, Corn. The idea was simple. Give the model a browser, let it check the facts, and the knowledge cutoff disappears. But here we are in March of 2026, and the reality is a lot messier than the marketing suggested.
Exactly why today's prompt from Daniel is so timely. He's asking about the state of play for search augmentation tools like Tavily. Specifically, he's noticing that while Google has baked search grounding directly into the model, it's proven to be pricey and, frankly, a bit flaky. He wants to know if these bolt-on search tools are still relevant, or if they're just legacy tech at this point.
It's a great question because the landscape has shifted underneath us just in the last few months. By the way, a quick bit of meta context for the listeners: today's episode script is actually being powered by Google Gemini 3 Flash. It's fitting, considering we're talking about the very ecosystem Google is trying to dominate.
It's like the model is writing its own performance review. I love it. But seriously, Herman, Daniel hit on something I've been feeling too. Native grounding feels like the easy button, but every time I use it for something niche, it feels like I'm paying premium prices for a search that misses the mark. Why is the built-in solution struggling so much?
It comes down to the architecture of the retrieval pipeline. When you use something like Google's Search Grounding API, which, let's remember, only went into wide release in January of this year, the model isn't just searching Google the way you and I do. It's an automated process where the LLM generates search queries, hits a specialized index, and then tries to ingest the top results. The cost is high. We're seeing an average of 1 cent per query. If you're running a high traffic agent, that adds up to a massive monthly bill very quickly.
1 cent per query is wild when you consider that a standard LLM inference call is now a fraction of a cent. You're essentially paying a 10 times markup just to make sure the model knows what happened yesterday. And the reliability? I saw a case study from just last month, February 2026, where a team was testing technical queries about the latest Rust borrowed checker improvements. Google's native grounding kept pulling up SEO-optimized blog posts from 2024 instead of the actual documentation updates from 2026.
That's the SEO spam problem we've talked about before, but it's magnified in the grounding context. Google's general search index is optimized for humans clicking on blue links. AI agents don't need blue links. They need raw, clean, structured data. When a native grounding tool prioritizes a high-ranking blog post over a low-ranking but more accurate GitHub pull request, the model gets confused. This is exactly where tools like Tavily, Exa, and Firecrawl have found their niche. They aren't trying to be Google for humans. They are building Google for machines.
I like that distinction. It's the difference between a library where the books are organized by how pretty the covers are and a warehouse where everything is barcoded for a robot. So, let's talk about Tavily. They had a big release just a few weeks ago, right?
Right, the March 2026 Tavily Query Update. What's fascinating about what they're doing is adaptive query expansion. Instead of just taking your prompt and tossing it into a search engine, Tavily's engine uses a smaller, specialized model to break your request into 4 or 5 different search vectors. It looks for documentation, recent news, and social sentiment simultaneously, then synthesizes those results before the main LLM even sees them.
And the benchmarks are starting to reflect that effort. I was looking at a study comparing Tavily against Google's native grounding on about 500 highly technical documentation queries. Tavily hit 87% accuracy, while Google was hovering around 71%. But the kicker was the cost. Tavily was coming in at roughly $0.003 per query, basically a third of the price of the native Google solution.
That cost to performance ratio is why Daniel is seeing people still reach for these bolt-ons. If you're a developer building a production-grade coding assistant or a financial analysis tool, you can't afford 29% of your answers to be based on outdated or incorrect search results, especially not when you're paying a premium for the privilege of being wrong.
It's funny, you'd think being the world's largest search company would give Google an insurmountable lead here, but it almost feels like they're hamstrung by their own success. They have to protect the human search experience, which is all about ads and engagement, while these specialized tools can just focus on pure data retrieval.
There's also the latency issue. Google's native grounding adds a significant delay to the response because it's doing this heavy-duty verification step. Tools like Exa, which used to be called Metaphor for those who remember the early days, take a completely different approach. They use neural search.
Neural search? As in, they aren't even looking for keywords anymore?
Well, I shouldn't say exactly because that's the forbidden word, but you've nailed the concept. Traditional search looks for the words Rust borrow checker improvements. X's neural search looks for the meaning of the query. It uses embeddings to find content that is semantically similar to what a high-quality answer would look like. It's looking for the shape of the information. This makes it incredibly effective for those niche technical queries where the keywords might be generic, but the context is specific.
I've heard of developers switching to Access specifically because they hit rate limits with Google, or because Google's filtered results were too sanitized. If you're looking for a specific bug report on an obscure forum, Google might hide that behind 3 pages of sponsored results. Exa just gives you the data.
And then you have the scraping side of the house. If Tavily and Exa are the search engines, tools like Firecrawl represent the ingestion layer. Firecrawl has become a bit of a darling in the developer community over the last year. Their whole pitch is turn any website into LLM ready markdown.
Which is a huge pain point. Anyone who has tried to scrape a modern JavaScript-heavy website knows it's a nightmare. You get headers, footers, cookie banners, and sign up for our newsletter pop-ups that just choke the context window of your LLM.
Firecrawl handles all the headless browser stuff, waits for the page to load, strips out the junk, and gives you a clean markdown file. It's basically a high-pressure car wash for the internet. When you combine something like Tavily for finding the URL and Firecrawl for extracting the content, you end up with a much higher signal-to-noise ratio than you get with native grounding.
So we're seeing a bit of a best-of-breed stack emerging. You don't just use Google. You use a search provider to find the data, a scraper to clean it, and maybe an embedding model like the ones from Gina AI to index it into your own temporary vector store.
It's a bit more complex to build, but the results speak for themselves. There was a case study from a startup in late 2025 that was trying to build a real-time market intelligence platform. They started with native grounding because it was one line of code to turn on. Their bill was $10,000 in the first month, and their users were complaining about hallucinated stock prices. They switched to a hybrid of Tavily and a custom Firecrawl pipeline. Their bill dropped to $3,000, and their accuracy went through the roof because they could specifically target financial data sources and bypass the general web noise.
That's the part that would keep me up at night if I were a product manager at Google or OpenAI. If the pro users are all building their own stacks because your built-in tool is too expensive and not accurate enough, you've basically created a market for your competitors.
It's the classic unbundling of search. Google is the bundle. It's great for how do I bake a cake, but once you need what are the specific breaking changes in the latest version of the PyTorch CUDA kernels, the bundle starts to fray.
I'm curious about the semantic search angle you mentioned with Exa. It feels like that's the real frontier. If we move away from keywords entirely, does that change how we prompt? I mean, are we going to reach a point where the search is just a model talking to a global vector database?
That's effectively what Exa is trying to build. They want to index the entire web as a single vector space. Instead of a search query, you're providing a directional vector. You're saying, find me the knowledge that exists at the intersection of distributed systems and low latency banking. It's much more fluid than the old school keyword approach.
But wait, if everyone starts using these tools to scrape and ingest data, aren't we just going to hit a massive wall of bot blocking? I noticed Daniel's notes mention Scrapegraph AI as a trending tool. It seems like we're in an arms race between the people who want to keep the data behind a wall and the AI agents that need to eat it.
It is absolutely an arms race. Scrapegraph AI is interesting because it uses LLMs to actually write the scraping logic on the fly. If a website changes its HTML structure to confuse a bot, Scrapegraph AI looks at the new page, says, oh, they moved the price tag to a different div, and rewrites the script in real time. It's using AI to bypass the anti-AI measures.
That's delightfully meta. I'm using an LLM to help me get the data I need to feed my other LLM. It's like using a robot to build a better spoon so you can feed a bigger robot.
It's the only way to keep up. The web is becoming increasingly hostile to automated retrieval. You've seen the reports. Over 40% of the top 1,000 websites now block the common AI crawlers. If you rely on Google's native grounding, you're limited to what Google is allowed to see and what they choose to show you. If you use your own bolt-on stack, you have more control over how you identify yourself and how you navigate those roadblocks.
So what does this mean for the average developer or the AI curious business owner? If I'm starting a project today, should I even bother with the native grounding? Or is it just a trap for the unwary?
I wouldn't call it a trap, but I'd call it a prototype-only feature. If you're just trying to see if an idea works, turn on native grounding. It's one toggle, it works well enough for 70% of things, and you don't have to manage multiple API keys. But the moment you move to production, the moment you care about the difference between a 1-cent query and a 0.3-cent query, you have to look at the specialized tools.
It's like the difference between buying a pre-made sandwich at a gas station and making one at home. The gas station sandwich is fine if you're starving and on the road, but if you're hosting a dinner party, you're going to want to pick your own ingredients.
And the ingredients are getting really specialized. We're seeing tools like Composio and Gina AI entering the mix to handle the orchestration layer. It's not just about searching, it's about what you do with the search results once you have them. Do you embed them? Do you summarize them? Do you use them to trigger a tool call?
I love the idea of search orchestration. It's basically a traffic controller for your AI's knowledge. Okay, this query is about a person. Send it to a social media search. This one is about a technical bug. Send it to Exa. This one is about a local event. Maybe use Google.
That is exactly where the high-end implementations are going. They use a routing model, usually a very fast, cheap one like a specialized Llama 3 variant to categorize the intent of the search. If the intent is fact-checking a recent news event, it routes to Tavily. If the intent is deep research into a scientific paper, it might route to a specialized academic index. This multi-search approach is how you get that 87% plus accuracy.
And that's something Google can't really do. They are incentivized to keep you within the Google ecosystem. They aren't going to route your query to a competitor even if that competitor has better data for that specific niche.
Precisely. Well, I almost said the P word there. But you're right, the platform lock-in is a real concern. By building your own retrieval stack with these bolt-ons, you're essentially de-risking your AI infrastructure. If Google changes their pricing or their terms of service, you can swap out the search provider without having to rewrite your entire application logic.
It's the vector debt problem we've touched on before. If you build everything around one proprietary grounding tool, you're stuck with their hallucinations and their price hikes.
There's another angle here that Daniel mentioned in his notes. The shift toward integrating real-time data sources directly into data warehouses like Google BigQuery. This is the enterprise version of search grounding. Instead of searching the open web, companies are grounding their models in their own massive internal datasets.
Which is a whole different ballgame. If you're a big bank, you don't care what's on Twitter, you care what's in your transaction logs from 5 minutes ago.
Right, and BigQuery is positioning itself as the grounding layer for the enterprise. They've made it incredibly fast to run vector searches across petabytes of data. So you have this split in the market, the open web search, which is being dominated by these agile startups like Tavily and Exa, and the private data search which is being fought over by the cloud giants like Google, AWS, and Snowflake.
It feels like the knowledge cutoff is being attacked from both sides. For the general public, it's about making the web searchable for AI. For the corporate world, it's about making their own silos searchable for AI.
And the tools that can bridge that gap are the ones that will win. Firecrawl is a great example because it can be used to scrape the internal wiki just as easily as it can scrape a public blog. It's a utility tool that doesn't care where the data is, as long as it's on a web page.
I'm still stuck on the cost difference, Herman. A factor of 3 or 4 is massive. If I'm running 1 million queries a month, which isn't that much for a popular agent, we're talking about the difference between $10,000 and $2,500. That's a developer's salary, or a whole lot of marketing spend.
It's the difference between a profitable product and a charity project for Google. And let's be honest, Google has a history of launching these APIs, getting everyone hooked, and then either raising the price or deprecating the service for a new and improved version that costs even more. The bolt-on ecosystem is a hedge against that kind of corporate unpredictability.
It's also about the quality of the scrape. I've noticed that when I use some of the cheaper grounding tools, I get a lot of hallucinated structure. The model thinks it's looking at a table, but it's actually a messy list. Firecrawl's focus on clean markdown seems to solve that.
It's a huge deal. LLMs are visual in a sense, they see the structure of the text. If the text is a jumbled mess of navigation menus and sidebar links, the model's attention is spread too thin. By giving it clean, structured markdown, you're letting it focus its full reasoning power on the actual content. It's like giving a student a highlighted textbook instead of a pile of loose-leaf papers found on the floor.
So, looking ahead, let's say we're in late 2026 or 2027. Do you think the bolt-ons will still be around? Or will the models just know the web? I mean, we're seeing continuous training experiments where models are updated every few hours.
Continuous training is the ultimate goal, but the compute cost of retraining a frontier model every hour is still astronomical. Until we have a fundamental breakthrough in how models learn, retrieval augmented generation, RAG, is going to be the standard. And as long as RAG is the standard, we need the retrieval part to be as sharp as possible. I think we'll see these tools move closer to the inference layer. Maybe you won't even buy Tavily separately. Maybe it'll be bundled into your inference provider as a search-enabled endpoint that uses multiple providers behind the scenes.
Like an aggregator of aggregators. The internet really is just turtles all the way down, isn't it?
Pretty much. But the turtles are getting faster and more efficient. What I find wild is how quickly the standard stack is evolving. A year ago, everyone was talking about simple vector databases. Now, we're talking about adaptive query expansion and neural semantic retrieval, as if they're basic requirements.
It's a high bar for entry. If you're a new player trying to build a search tool for AI, you can't just be Google but for bots. You have to be Google but for bots, plus a scraper, plus a summarizer, plus an embedding model, and it has to cost 1/10 of a cent.
And you have to do it all with zero latency, because if the search takes 5 seconds, the user is already gone. That's another thing Tavily does well. They've optimized for time to first byte. They know the LLM is waiting, so they stream the results back as they find them.
I remember when we used to wait 30 seconds for a page to load on dial-up. Now we're complaining if a robot takes 2 seconds to read the entire internet and summarize it for us. We really are spoiled.
We are, but that's the pace of the industry. If you aren't spoiled today, you're obsolete tomorrow.
That should be the tagline for the show, honestly. So, if someone is listening to this and they're feeling overwhelmed by all these names, Tavily, Exa, Firecrawl, Scrapegraph AI, what's the start here advice?
Start with Tavily if you need general web search that's better and cheaper than native grounding. It's the most drop-in replacement. If you're building something highly technical or academic, give Exa a look because their semantic search is unmatched for finding that needle in a haystack documentation. And if you're trying to build your own knowledge base from specific sites, Firecrawl is the gold standard for getting clean data.
And don't forget to check the bill. If you're still using native grounding in production and you haven't looked at your API costs lately, you might be in for a nasty surprise.
Definitely. Or rather, I won't say the D word either, but yes, monitor those costs. The convenience tax of native grounding is real, and as Daniel pointed out, it's not always buying you better quality.
It's the classic build versus buy, or in this case, integrated versus modular. For most serious developers in 2026, modular is winning. It gives you the flexibility to pick the best searcher, the best scraper, and the best model for your specific problem.
And that's the beauty of the current ecosystem. We have these specialized tools that are all fighting to be the best at one specific part of the pipeline. It's a great time to be an orchestrator.
Even if it means you have to keep track of 5 different API keys.
Small price to pay for 87% accuracy and a 70% discount.
Fair point. I'll take the API keys over the hallucinated stock prices any day.
Wise choice. It's also worth mentioning that as these tools evolve, they're becoming more agentic themselves. Tavily isn't just returning links, it's starting to return reasoning chains about why it chose those links. It's helping the main LLM understand the why behind the data.
That's a huge step forward. It's not just here is a fact, it's here is a fact, and here is the context that proves it's the fact you actually asked for.
It reduces the cognitive load on the main model. If the search tool does the heavy lifting of sorting and verifying, the main model can spend more of its tokens on actually answering the user's question.
It's like having a really good research assistant. You don't want them to just dump a pile of books on your desk. You want them to have the right pages bookmarked and the key sentences highlighted.
That is the perfect way to look at it. The bolt-on tools are becoming the expert librarians of the AI world.
Well, I think we've given Daniel a lot to chew on here. It's clear that the death of the search bolt-on was greatly exaggerated. If anything, they're more essential now than they were a year ago, because the gap between good enough and production ready is getting wider.
It's the difference between a toy and a tool. Native grounding is a great toy, but the modular stack is the professional tool set.
And on that note, I think it's time to wrap this one up before I start making more analogies about gas station sandwiches.
Probably for the best.
Thanks as always to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes.
And a big thanks to Modal for providing the GPU credits that power this show. They make the heavy lifting look easy.
This has been My Weird Prompts. If you enjoyed our deep dive into the world of AI search, do us a favor and leave a review on your favorite podcast app. It really does help other people find the show.
We'll be back next time with another prompt from Daniel. Until then, keep your models grounded and your search queries adaptive.
Catch you later.
Jugogai.
This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts, that's the flows from slow